Okay, so why did I spend time making review videos over how to graph linear equations and how to graph quadratic equations? Well, it's because one of the first things that we have to be able to do in this very short chapter is we have to be able to graph what's called a system of equations. A system of equations is where we have more than one equation. We're trying to find out when these two equations will be equal to each other. And one of the easiest ways to find the solution to a system of equations is to simply graph them and find their point of intersection or points of intersection. So we've got a sample system down below. Y is equal to 2x minus 1 and y is equal to 2 over 3x plus 3. What values of x and y would be a solution in both the top equation and the bottom equation? So to kind of see what's going to happen here, we're going to graph both equations. We're going to start with y is equal to 2x subtract 1. So I can see this is a linear equation, mx plus b. And I'm going to find my b value. I'm going to find my slope. We can see b lines up with -1, and m lines up with +2. So I'm going to turn that 2 over 1 as a fraction. So I know on my y-axis I need to find -1. And from there, we know that our slope is +2 over 1. So from here I'm going to go up 2 to the right 1 and put another point. Now we kind of continue this pattern several times where I'm going up 2, right 1, so that I have several points. Now, since I'm graphing a linear equation, we're really trying to be as accurate as possible here, trying to find out where these two equations will cross. I would suggest you use something that's straight, like your student ID, to connect the dots here. And we'll draw the line out as straight as possible. Make it a perfectly straight line. Okay, and so our next line, we've got the y is equal to 2 over 3x plus 3. Again, we've got another linear equation, so we want to start by finding our b value, which in this case would be +3, and our slope, which is 2 over 3. So we're going to find +3 on the y-axis, and then our slope, we've got rise 2 and run to the right 3. So from our starting point, we're going to go up 2, right 3. We're going to go up 2 and right 3 spaces. We can see that we've already got a point where they're intersecting. So we're going to draw a straight line as perfectly straight as we can. And that gives us our straight line for the second equation. So the 2 over 3x plus 3. Now, what this is telling us is this point right here, where the green line and the red line cross, at 3, 5, is the solution to this system. So what that's going to tell us is if we take either of these equations, so y is equal to 2x minus 1, if I use x is 3 and y is +5, so we've got 2 times +3 minus 1. We have 2 times 3 would be 6 minus 1, which would be 5. So that would give us our y value. Now if I use the second equation, y is equal to 2 over 3 x plus 3, and I use the same values, 3 and 5, we've got 2 divided by 3 times 3 plus 3. Times 3 divided by 3 cancel out, leaving us y is equal to 2 plus 3, which is y is 5. So for both of these equations, we would get the same exact result with the same value of x. And that's kind of what we're going for on this. What values for x and y cause the system, or the two equations, to be equal to each other. So for a second example, we have y is equal to x squared plus 4x plus 8, and y is equal to -x plus 2. I'm going to start with the linear equation just because it's a little bit easier to do. I'm going to graph this equation, mx plus b. I can see, well, b would be positive 2. My slope is a negative, but I'm going to assume that's a negative 1, and I'm going to turn that to a fraction, negative 1 over 1. So positive 2 on the y-axis, and then up from there I'm going to go down 1 and to the right 1. I'm going to go down 1 and right 1. I'm just going to kind of continue that pattern several times so that I can get several points on the graph. And then I'm going to connect the dots. I'm going to connect it as straight as I can. And then I'm going to also go back the other way. So there's y is equal to negative x plus 2. Now I'm going to graph the second equation, the quadratic, y is equal to x squared plus 4x plus 8. So I know that this one is a quadratic because it has that x squared in it. So the first thing in graphing a quadratic is we have to find the vertex, where we've got x is equal to negative b divided by 2 times a. I can see b lines up with positive 4, and a doesn't have a value, so we're going to say a is 1. We fill in our equation. We've got a negative of b divided by 2 times a. So we've got a negative of 4 divided by 2 times 1. We start to work that out. So negative 4 divided by 2 being negative 2. Now we're going to take that answer, negative 2, we're going to substitute it in for x in the equation. So we've got y is equal to x squared plus 4x plus 8. We're going to replace both of the x's with a negative 2. So negative 2 squared would be positive 4. 4 times negative 2 would be negative 8. And then we've got plus 8. I know negative 8 plus 8 would cancel out, leaving us with just y is 4. So our first point would be negative 2 comma 4. Now in the previous video we said, hey, a pattern that we can use on a quadratic is where we go right 1, up 1, or we go right 1, up 3, and right 1, up 5, and then reflect it going back to the left. So on here, I'm going to go right 1, up 1. I'm going to go right 1, up 3, and then I'm going to go right 1, and I would go up 5. Okay, which gives me half of the parabola, and then I would do the same thing going back the other way, where it's just going to be reflected. And we can see that this time we have two solutions. We have the vertex, and then we also have the second point right over here to the left. So our two solutions to this system we've got negative 2, positive 4, and our second point was negative 3, positive 5. And just like the previous equation, if we plugged in those values for x, both equations should give us the same solution. And those would be the only 2 points where those two equations would be equal to each other. So for our final example, we have y is equal to x squared plus 6x plus 11, and y is equal to negative 1/2 x minus 1. So just like the last problem, I'm going to start by graphing my linear equation first, where I've got a y-intercept of negative 1, and I've got a slope of negative 1/2. So when I go to put those on the graph, I'm going to start with my y-intercept. The y-axis, I'm going to start at negative 1. And we've got a slope of negative 1/2, which means I'm going to go down Since our slope is negative, that means our rise is going to be going down. Our run is still to the right. So down 1, right 2 spaces, put a point. Right 1, down 2 spaces, put a point. And I would do this several times just so I've got enough points. And we should see a point that kind of arises, or we've got our equation. Connect the dots on both sides, make it look as straight as possible. Now our second equation, we can see, hey, this time we've got a quadratic again. Y is equal to x squared plus 6x plus 11. So on this, we're going to start by finding our vertex. And the formula to find the vertex is negative b divided by 2 times a. So we've got a negative of 6 divided by 2 times a, and just like the last problem, a is going to be a positive 1. So we get negative 6 divided by 2, which would be negative 3. Now we're going to substitute that into the equation. So we've got our y is equal to x squared plus 6x plus 11. We're going to replace both of the x's with our negative 3 answer. We're going to start to work it out. So negative 3 squared would be positive 9. 6 times negative 3 would be negative 18 plus 11. We end up with a positive 3. So what that's going to tell us is our first value, or positive 2, I'm sorry. And so what that's going to tell us our starting point is if x is negative 3, our y value was positive 2. So there's our starting point, negative 3, positive 2. And there's our vertex. And just like the last problem, we said, hey, with a quadratic, we can go right 1, up 1, and then right 1, up 3, and then right 1, up 5, if we have room. So right 1, up 1, put a point. I'm going to go right 1, up 3, put another point. Right 1, up 5, put another point. And then I would reflect it going back the other way. Now we can kind of see a general pattern from this, is where do the red line and the green line cross? Well, the fact of the matter is they don't cross. So if they don't cross, that would tell us that there is no solution to the system of equations. And so that's going to be something that we're going to be seeing, or we might see on a test on the district assessment. However, none of the equations that you have on your assignment will be a no solution. Again, that's probably only going to be seen on a district assessment. Hint, hint. I hope you guys understood what I was going over on this. Please submit a copy of your notes, which means you may need to pause this video, go back, and rewind it, and rewatch parts of it if you didn't catch something. If you have any problems, please comment on the post below in Google Classroom, and I'll try to get back to you tomorrow during class. Have a good day, and I'll see you guys next week.